Good morning, students. Welcome to 11th Standard Physics online class. Today, we are going to understand the concept of measurement from the first unit, Nature of Physical World and Measurement. Physics is a quantitative science. Physicists always deals with the numbers which are the measurement of quantities. Physics is a quantitative science, which means physicists always deal with the numbers which are the measurement of physical quantities. Measurement plays an important role in our daily life. You all know that when you buy things from shop, you need some measurement in terms of 5 kilogram of rice, 2 kilogram of sugar, 3 liter of milk, etc. So measurement plays very important role in our daily life. Measurement is the basis of all scientific studies and experimentation. What is measurement? Comparison of any physical quantity with its standard unit is known as measurement. So with the standard unit, we are comparing physical quantity. Physical quantity. What do you mean by physical quantity? You may have heard some of the physical quantities such as length, mass, time, force, energy and all. Quantities that can be measured and in terms of which laws of physics are described are called physical quantities. Quantities that can be measured and in terms of which laws of physics are described are called physical quantities. Example, length, mass, time, force, energy, etc. Types of physical quantities. There are two types of physical quantities. They are fundamental quantities and derived quantities. Fundamental quantities and derived quantities. Fundamental quantities otherwise called as base quantities. What do you mean by fundamental quantity? Fundamental quantities are quantities which cannot be expressed in terms of any other physical quantities. Fundamental quantities are quantities which cannot be expressed in terms of any other physical quantities. Example, length, mass, time, electric current, temperature, luminous intensity and amount of substance. These are the examples of fundamental quantities. Derived quantities. Quantities that can be expressed in terms of fundamental quantities are called derived quantities. Quantities that can be expressed in terms of fundamental quantities are called derived quantities. Example, area, volume, velocity, acceleration, etc. Example, area. Area means length into breadth. Length is a fundamental quantity. Breadth also measures distance. So, length into breadth is equal to area. So, area is derived from the fundamental quantity length. So, it is a derived quantity. Similarly, volume. Volume means area into height. Here also, this volume is derived from the fundamental quantity length. Velocity. Velocity means rate of change of displacement. So, displacement and time are the fundamental quantities. Velocity can be derived from displacement and time. So, these are the examples of derived quantities. So, fundamental quantities and derived quantities we have discussed. Now, Units. To measure a quantity, we compare it with some reference standard. In order to measure one quantity, we need a reference standard that is known as unit. To measure a quantity, we compare it with some reference standard. For example, consider a rope which is 10 meter long. What does it mean? The rope is 10 times the length of 1 meter. Here 1 meter is the reference standard unit. We are comparing the length of rope as 1 meter. That is 10 times the length of 1 meter. So, definition of unit. Define unit. An arbitrarily chosen standard of measurement of a quantity which is accepted internationally is called unit of quantity. Define unit. An arbitrarily chosen standard of measurement of a quantity which is accepted internationally is called unit of quantity. Types of units. Fundamental units, derived units. What are the two types of units? Fundamental units and derived units. Fundamental units are used to measure the fundamental quantities. The units which is used to measure fundamental quantities are called fundamental units. Example, what is the unit of length? Meter. So meter is a fundamental unit. What is the unit of time? Second. Second is the fundamental unit. Derived units. Derived units are units which is used to measure the derived quantities. Derived units are units which is used to measure the derived quantities. Derived quantities unit can be obtained by suitable multiplication or division of power of fundamental units. Derived quantities unit can be obtained by a suitable multiplication or division of power of fundamental units. For example, unit of area. Area expression is length into breadth. Area is length into breadth. What is the unit of length? Meter. What is the unit of breadth? It is also meter. So area can be written as length into breadth. Units can be written as meter into meter. That is equal to meter square. So unit of area is meter square. So derived quantities unit can be obtained by suitable multiplication of power of fundamental units. Power of fundamental units. Okay, two types of units we discussed. Fundamental units and derived units. Now we can move on to different types of measurement system. 3 measurement systems are given in your book. The FPS system, the CGS system, the MKS system. What are they? The FPS system, the CGS system and the MKS system. FPS system is the British engineering system of units, which uses foot, pound, second. Foot, pound, second. That is used to measure length, mass and time. Length, mass and time. The CGS system. CGS system is Gaussian system. The CGS system is Gaussian system, that is centimeter, gram, second. Centimeter, gram, second. It is also used to measure length, mass and time. Length, mass and time. The MKS system. MKS system is meter, kilogram, second. Meter, kilogram, second as the three basic units of measuring length, mass and time respectively. So these are the different types of measuring systems. So different places, different measurement systems they used for same physical quantities. It is very difficult to communicate between the people around the world. So common unit of system were introduced. That is known as SI unit of system. This is the internationally accepted system of unit. SI unit of system. This is a internationally accepted unit of system. The expansion is Systemi International. Systemi International. The system of units used by scientists and engineers around the world. SI system were developed and recommended by the General Conference on Weights and Measures in 1971. Till 1960, it is commonly called as metric system. After that, 1971, General Conference on Weights and Measures introduced the name SI system. So we are practicing the SI system of unit. What are the advantages of SI system? Let us see. There are three main advantages. It is a rational system of units. It is a coherent system of units. It is a metric system of units. What are they? It is a rational system of units. It is a coherent system of units. It is a metric system of units. What is rational system of units? This system makes use of only one unit for one physical quantity. This system makes use of only one unit for one physical quantity. It's a constant unit. For length, only the meter is used. For time, only the second is used. For current, only the ampere is used. So only one unit for one physical quantity. Coherent system of units. What do you mean by coherent system of units? Derived units can be easily obtained from basic and supplementary units. In this system, all the derived units can be easily obtained from basic and supplementary units, which means it is a coherent system of units. So from the basic units meter, kilogram, second, we can easily get the unit of derived quantities. That is, derived units can be obtained. Metric system. What is metric system? Which means that multiples and submultiples can be expressed as powers of 10. Multiples and submultiples can be expressed as powers of 10. This is metric system. That is powers of 10. 10 power 2, 10 power 3, 10 power 5, 10 power 6. That multiples and submultiples can be expressed as powers of 10 in this system of unit. So these are the advantages of SI system. What are the advantages of SI system? It is a rational system of units. It is a coherent system of units, and it is a metric system of units. So far we have seen what is meant by measurement, comparison of a physical quantity with its standard reference unit, and what is meant by physical quantity. What are the two types of physical quantity? Fundamental quantities and derived quantities. Units, definition of units and its types. Fundamental units and derived units. Next, three different types of measuring units. FPS system, CGS system, MKS system, and SI system and its advantages. Now, let us see the basic quantities and their units. It is very important. You may have already learned in the lower classes. Okay, listen. Basic quantities and units. Quantity, unit, simple. There are 7 fundamental quantities or 7 basic quantities. What are they? Length, mass, time, electric current, temperature, amount of substance, luminous intensity. What are they? Length, mass, time, electric current, temperature, amount of substance, luminous intensity. Length, which measures distance. Mass, which measures weight. Time, which measures duration. Electric current means measuring flow of charges. Temperature, measuring the degree of hotness or coldness. Amount of substance, substance amount. Luminous intensity means light intensity. So these are the fundamental quantities. Now let us see the unit. What is a unit of length? Meter. So symbol is small m. What is a unit of mass? Kilogram. Symbol is kg. What is a unit of time? Second. Symbol is s, small letter s. So length unit is meter, mass unit is kilogram, time unit is second. What is the unit of electric current? Ampere. The unit is capital A. What is the unit of temperature? Kelvin. Unit is K. What is the unit of amount of substance? Mole. Unit is MOL. What is the unit of luminous intensity? Candela. Symbol is CD. So electric current ampere, A, temperature Kelvin, K, amount of substance mole, MOL, luminous intensity candela, CD. So students are asked to write the basic quantities and its unit in your notebook. Now let us see some of the derived quantities and their units. This also you have to practice in your notebook. Few derived quantities are familiar to you and few are not familiar to you. That can be understand from the upcoming chapters. Okay. Derived quantities and their units. So derived quantities, the quantities can be derived from the fundamental quantity. Physical quantity, expression, unit. First one, area. What is the expression? Length into breadth. Length into breadth. What is its unit? The unit of length is meter. Unit of breadth is meter. So meter into meter, meter square. Understand? Next, volume. What is the expression for volume? Length into breadth into height or area into height. So here length, breadth, height, everything measures the distance. Everything measures the distance. So we can write for length meter, for breadth meter, for height meter. So meter into meter into meter, meter cube. Next, velocity. What do you mean by velocity? Rate of change of displacement. That is displacement divided by time. Displacement divided by time. What is the unit of displacement? Meter. What is the unit of time? Second. So displacement by time. So meter by second or we can write meter second raised to minus 1. Okay, this is velocity unit. What is the unit of velocity? Meter second raised to minus 1. Next, acceleration. What is acceleration? Rate of change of velocity, or we can write velocity by time. Already we have discussed about the unit of velocity. What is it? Meter second raised to minus 1. So we can write velocity unit is meter second raised to minus 1 per time, or divided by time. So divided by second. So it can be written in the numerator as second power minus 1. So m s power minus 1 s power minus 1 m s raised to minus 2. So what is the unit of acceleration? Meter second raised to minus 2. Next, density. What is density? Mass per volume. Mass per volume. So what is the unit of mass? Kilogram. What is the unit of volume? Meter cube. So how can we write kilogram meter raised to minus 3 is the unit of density. Mass per kilogram, kilogram per meter cube. So kilogram meter raised to minus 3. Linear momentum. That is momentum. What is momentum? P equal to m into v. Mass into velocity. What is the unit of mass? Kilogram. What is the unit of velocity? Meter second raised to minus 1. So we can write kilogram meter second raised to minus 1 is the unit of linear momentum. Moment of inertia. What is the unit of moment of inertia? First expression. Expression mass into square of distance. So mass in distance square. That is unit of mass is kilogram. Unit of distance is meter. So we can write kilogram meter square. Force. Already you know the familiar unit of force. What is the unit of force? Yes, Newton. So force expression, force equal to ma, mass into acceleration. Mass unit is kilogram, acceleration unit is meter second raised to minus 2. So kilogram meter second raised to minus 2, or else we can write Newton, capital N. Pressure. Pressure. What is the unit of pressure? First expression. Expression for pressure is force per area. Force already we have discussed. Newton or kilogram meter second raised to minus 2. So here we are using Newton per area. So divided by meter square, or we can write Newton meter raised to minus 2. Otherwise Pascal. That is also the unit of pressure. Energy. Energy, or we can call it as work done. Work. Force into distance. So unit of force is Newton, distance is meter, Newton meter, or we can write joule. Next, power. What is mean by power? Rate of doing work, or work divided by time. Can write work unit is joule and time unit is second. So joule per second or joule second raised to minus 1. Otherwise we can write this. The unit of power is watt. These all are scientist names. Derived units. Next one, impulse. Impulse, force into time. So force unit is Newton, time unit is second. So Newton second. Next, surface tension. Surface tension, force per length. So force Newton per length per meter, or we can write Newton meter raised to minus 1. Electric charge. Electric charge, current into time. What is the unit of current? Ampere. So unit of time, second. So ampere second. Now, plane angle and solid angle. These two quantities are actually the supplementary quantities which was converted into derived quantities in 1995. Plane angle and solid angle are supplementary quantities was converted into, these two are converted into derived quantities in 1995. So what is a unit of plane angle? Plane angle expression is r per radius. Unit is radian. R-A-D. Symbol R-A-D. Solid angle, surface area per radius square. So the unit of solid angle is stradian. Some other derived quantities also given in your book, that is new quantities to you, such as magnetic induction, force constant, Planck's constant, specific heat, Boltzmann constant. These are also you have to learn. Magnetic induction means force by current into length. So Newton by ampere meter, or Newton ampere raised to minus 1 meter raised to minus 1, or Tesla. Force constant, force per displacement, we can write Newton meter raised to minus 1. Planck's constant, energy of photon by frequency. Energy unit is joule. Frequency is reciprocal of time. So we can write the unit as per second, or we can write as joule second. Frequency is 1 by time. So per frequency. So here we can write as joule second. Specific heat, heat energy by mass in temperature. Energy unit is joule. Mass unit is kilogram. Temperature unit is Kelvin. So joule, kilogram, per minus 1, Kelvin per minus 1. Boltzmann constant, energy per temperature. Unit of energy is joule. Temperature unit is Kelvin. Joule, Kelvin raised to minus 1. So students, you all are asked to write the basic quantities and derived quantities in your note with the units. Students, we learnt basic quantities and their units, derived quantities and their units. Now, some of the prefixes for powers of 10 also I am explaining. Prefixes for powers of 10. Multiple prefix symbol. For 10 power 1, deca, symbol DA. 10 power 2, hecto, symbol H. 10 power 3, kilo, symbol K. 10 power 6, mega, symbol M. 10 power 9, giga, symbol G. 10 power 12, tera, symbol T. 10 power 15, peta, symbol P. 10 power 18, exa, symbol E. 10 power 21, zeta, symbol Z. 10 power 24, iota, symbol Y. So 10 power 3 gram means kilogram, or kilogram means we can write 10 power 3 gram. Mega means we should write 10 power 6. Giga means we should use 10 power 9. These are the prefixes for this powers of 10. Similarly, submultiple prefixes also we should learn. Submultiple prefix symbol. 10 power minus 1, deci, symbol D. 10 power minus 2, centi, C. 10 power minus 3, milli, M. 10 power minus 6, micro, mu. 10 power minus 9, nano, N. 10 power minus 12, pico, P. 10 power minus 15, femto, F. 10 power minus 18, auto, A. 10 power minus 21, zepto, Z. 10 power minus 34, yocto, Y. So students, when the prefix millimeter means, you should use the multiple, submultiple as 10 power minus 3 meter. When there is nanometer means, you should use the 10 power minus 9. This will be useful for Solving problems. Micro means we should use 10 power minus 6. Pico means we should use 10 power minus 12. Centimeter means we should use 10 power minus 2 meter. So these all are the prefixes for powers of 10. So today we have discussed about measurement, the concept of measurement, physical quantity, types of physical quantity, units and its types, different types of measurement systems, SI units of system and its advantages, and also basic quantities and derived quantities and their units. I hope you all understand today's concept. Please try to learn the question answers of the following. What is physical quantity? Briefly explain the types of physical quantities. Define unit. Give the 3 different types of measurement of systems. Give the advantages of SI system. Also learn the basic quantities, physical quantities, derived quantities and its unit. Thank you.